Okay, folks. So let's get the Raspberry Pi up and running. So this will be it's really the last video you need. I'll do a supplemental video where we have a module that purely just sends state data, and maybe with a sound detector and a relay switch or a temp sensor or something like that. But really, this is going to be the last one you need to get the front end and the Pi and the Arduino talking to each other. Now what I'm going to do is I'm going to just clone this code here on my PC just to talk about it, and then I will clone it on my Raspberry Pi. How you choose to do it is obviously up to you. You probably want to clone it on your Pi, and then you could just install VS Code right on your Pi. If you have the 32-bit version of VS Code, it's as simple as opening a terminal and just sudo apt install code. If you have the 64-bit version, you'll have to go to VS Code's website, scroll down to the bottom of the downloads page, and you'll find the 64-bit ARM version of Debian, just Debian version of VS Code, and then just download it and install it. If you're interested in getting VS 64-bit version of the Raspberry Pi operating system on your Pi, check out Q Engineering's tutorial here. They have some other amazing stuff here. You might want to check it out. So you could just do this part, and this will walk you through getting the 64-bit OS on your SSD card. But if you wanted to, at the end, you could also get it going on a I'm sorry, I think I said SSD, but this would just be on your SD, right? Your micro SD card. If you wanted to use a solid-state drive plugged into one of USB 3 ports, they also show how to do that too. So you might want to check that out. Okay, so let's come here and let's go ahead and copy this. And I'm going to open up a shell, and we'll clone that, and you can just open up code, browse to the folder if you want, however you choose to open it up. Okay, so let's start with app. If you haven't spent any time with working with Express and Socket.io together, I would check out Socket.io's website. Gives you some good information. Maybe do that quick chat tutorial they have or something like that. Might make things easier here, but you don't need to get through this. Let's see here. We'll talk about the things that aren't obvious here in a second. Let's see. You don't need this chunk unless your front end is running on a different server, a different port, even than your back end and your Express server. But it's not in our case, right? Express is serving up our front end, so we really don't need this. But if you end up putting your front end somewhere else, then you would need that, and it doesn't hurt anything to have it. This just serves up our index.html. I guess we don't really need public there, but and then we have the connection event. So if we do io.on, every time that somebody connects to our server, what we want to do is we want to give them an update. So we want to send an update from the server to the client, right? And that's in our index.html here. Right now we're actually sending this, right? io.on is inside of JS, and we'll take a look at that in a bit. So what we do is this, right? We have required all of the radios inside of the radios folder. You don't really need index here. If you require a folder, it's going to look inside of that folder for index anyway. So what we do is when we require that folder, we go inside of source and inside of radios, and basically this is what's getting loaded up. And what this is going to do is it's going to load up each of our radios. So here's the good part. Let's say you added a radio called garage.js. Well, all you do is copy this line, and you would add that, right? Control V, garage. You would come here, do Control C and Control V, and then garage and garage. And then all you would do from there is you would just grab this. Might as well finish it here, and I'll actually do this in that final video. But let's add a new file. All right, and we could pop this in here. Our on event is going to be garage, and we need to put obviously the MAC address of that radio here, and that's it, right? That's all you would have to change. And the good part is the rest of your code, right, looks inside of the key value pairs inside of radios. And what are the key value pairs? Well, the radio is going to be a key, and then the value is just the, right, this constructor function, the address, and the state object here, right? So it'll iterate through all of those and then send an update. And notice that we're holding the state locally right here, that we get back from the remote modules, right? Okay, so let's come back. Let's come back to. We don't need that open anymore. So that's that. I mean, if you didn't do it this way, right, iterate those key value pairs, what you would have to do is you'd have to keep adding a line similar to this every time you added a new radio, like garage, right? So, you know, in my case, I have, you know, probably 7 or 8 of them floating around here, and it's kind of a pain to have to go through and change the code in so many places. So now, right, this never has to change. Every time you add a radio, you just add the radio, and everything else would work perfectly. Okay, so that's that. So you might be thinking this, right? What happens the very first time somebody logs on, right? So the very first time somebody browses to your server. Well, in that case, right, if we didn't do anything, there wouldn't be any state that's held, right? So you wouldn't know what the actual state of each of the radios is, right? So everything would just be blank. And the way I address that is, if we look inside of Xbee Serial, right? So we load up Xbee Serial up here, right? So we load it up. Although we don't need it anywhere here. Yeah, we do. Actually pass it here. But it gets loaded up here, and the good part is, what's going to happen is, once we load that up, right, the Xbee Serial is going to connect, right? We have the open event, and inside of the open event, what you're going to see is I do the exact same thing. And this only runs once when it actually connects. And what's going to happen is it's going to go through and it's going to request an update from each of the radios. So I think if you watched that video, hopefully you did, you'll notice that we listened for 6 bytes. Again, it didn't matter what the 6 bytes were. I just happened to pass, right, the word update here, but it could be 6 zeros. So what we do is we send update. We have the address that we want to send it to, and if we go down to the send function, what that's going to do is it's going to send a request for an update from that radio. That radio is going to send back an actual update, and then the client app gets updated. So this is only necessary for the very first time that you run your application, right? So when you first start it up, now the state of each radio is held in memory, right? And that's, oops, so I didn't do that one, right? Will be held here, right? Every single one of the pins that you have. Okay. So let's. I didn't want to come here. I wanted to go. I want to go here. Did I close? Oh, I guess I did. I closed it up. Let's come down to here's basically, you could think of this as our listener. Oops, shift your fingers. E-E-N-E-R. So here we're listening for the information that's coming from the remote radios, right? And that would be a frame type of 144, right? So we have data that's coming in, right? So we have this data event, just calling it frame. And inside of that data event, there's going to be a type. If type is 144, I think there's some constant names for this if you look inside the Xbee API library. But if it's 144, we know that we got information from a remote radio that we sent, right? So all we do here is this just matches up. As opposed to, remember the C code, C++ code, where we had to kind of iterate through all of, let's say, all of the pin objects in our pin array, and look for one that has a number that matches the data that came in, the pin number that came in. Well, it's a little bit easy here to use this fat arrow syntax to match up, and that's all we're doing, right? The remote radio, the remote packet that came in, we know what radio it is, right? It's called remote 64 inside of that frame, and inside of each of our radios, we have an address, right? And we just match those up, so we know that this is the radio that we need to update. So if the length of the frame is 2, well, in that case we have a pin and a state, right? So what I do here is, right, what we do is we build that property name on the fly here. If it exists, it's fine, but if not, we end up with inside of, so I should double click and leave this open, so, but inside of here, right, basically we end up something like, pin 2, and then some value, right, whatever that is. In the case of hex, and that would be the next line, we'll look at that in a second, it would be pin, something like pin 9 or something, and then that's going to be an actual object, and there'll be an R with 255, a G with whatever that value is, and a B with whatever that value happens to be, right? So we just keep storing the state inside of this state object. Excuse me. Right? So that's what this line does right here. So once again, right, if there isn't that property, right, if it exists already, it'll just update it. But if not, it'll add that property, and again, it'll just be pin and the pin number, which we pull out of the data. And then I create an object here of the RGB, right? And then we do an io.emit, and that gets emitted to the JavaScript for our client app, and we'll look at that when we get there. That's it, right? That's not so bad, right? And again, as far as what you have to change, well, the only thing you have to change is go into that bench radio and put your address here. Obviously, don't do this. I was just simulating what happens in memory. So all you have to do is just put and I'll do that in a second when we get there. Anything else? I think that should cover it. If you're relatively new to this, put a bunch of debugs in here. Right? By the way, you can set up your radios to send data on its own about the state of the pins on the radio itself, as opposed to the state of the pins on the Arduino. And I do have a video on that. So I think I have code on the repo too. So basically, what you could do is you could have something like a reed switch attached to one of these pins, and if that reed switch opens or closes, the radio will just automatically send an update, and you would get that update here. Those pins start with DIO0, and I think that would be pin 11. So the right side top pin, no, that would be pin 20. So they go 1 through 10, 11 through 20. So it would be the top right if you're looking at your radio. Did we look at the send function here? Anyway, I don't know. So when we send data from obviously the coordinator to a remote radio, I just make sure it has a payload. I actually make sure that it has a payload in the JavaScript for the front end too, but it doesn't hurt. So the data is going to come through. We'll look at what that data looks like in a second that comes through here. And if there's the is hex property is true, we know we get a hex value. So we just pull out the RGB out of that hex triplet, and we add it to the data.payload. Right? Let's see here, and then we grab the pin and then we push the pin on too. Now, if hex is false, you notice we skip this altogether because the only thing inside of data is just a pin, and it's a pin to toggle, right? And we're just sending that to the other side, and we saw that in the Arduino code, so we're sending a 4. If the Arduino gets a 4, it toggles pin 4. So we don't need to change anything in that case. And we're using the Xbee API NPM package here to build this frame, so it's a little bit easier than we did on the Arduino side to build a frame and actually send it. And again, as I had mentioned, the library that we used has the ability to do it. I just didn't, right? So poking at it, I didn't get it to work, so I just did it by hand. So anyway, our payload's going to either be a pin, or it's going to be a pin with an RGB to set. And we just write that off, and this is the write inside of that Xbee API library. And that's about it. You know, obviously I've probably missed a whole bunch of stuff. I left some of the longhand code here, just so you could see how verbose it is every time you add another module, as opposed to this, which never changes if you add another module. Doing it this way, which is the old way that I did it, it's obviously a heck of a lot more. You got to go change code everywhere. Kind of think about it, you'd be changing code inside of app, right? So I'd be changing code here, I'd be changing code inside of here, and a couple of places inside of here. So it makes it a nightmare to add a radio. This way, it's really just add a radio, and you're good. Everything else just works. Okay, so now let's look at the client stuff inside of public. So here's our index.html, and this is relatively straightforward. You'll notice that my check boxes, I have them in a collection, and the way I name them is just the radio. So bench, this has to match up with, right, inside of source, inside of radios, with this, right? So that's going to match up with that. Technically, the name doesn't have to be the same, but it just makes sense to do that, right? Let's close the rest of this stuff. And we don't need that anymore. Okay, so that matches up. Then we're just using a hash sign here to separate. Then the actual pin number, and I just added the fact that it was a span, so I could name the ID of each of these the same. Might have been a better way to do that, but it works out. So then we have bench, right? Pin 9, and span is just there. But the important part is it all has to be there properly, and I'll show you why in a second. You know, the radio that it's going to, and then the pin. So here's the cool part. I mean, if you wanted to add another one, just copy this, right? Come down, and you could come here and say, hey, you know, this is going to go to garage, and you would change this to garage. And now this is going to, this would end up lighting up an LED that's on, right, garage module on pin 9. Right? And that's it. It's that simple. You wouldn't need to change any other code. That's all you have to do. As far as the chunk for the buttons, if we come down here, we have a button for our breadboard LED and one for our lamp. So we'll look at the send data function in a minute, but basically what we do is we send, right, and again, this is going to match up with, right, inside of your actual radio with that right there, right? So we're going to do a MIT to bench. We have our pin number. This is not hex, so that is hex we checked. And we don't need a pin number here in this case because we have our pin right here. And this is our payload in this case. And then we do the same thing, right? So bench #4 #button. Now technically you don't really need this here because I don't have anything else named bench #4 like I up here. You know, I had a span and an ID. And there's probably a better way to do that, but you know it worked for this, and you at least get the idea here. And again, if you wanted to add another button, just copy and paste one of these lines, and then, you know, garage. and just change this to garage. And then that's it. Right now, this is going to send an update to the radio garage, right? So that would send over here. Now we don't have any of the code here, but you would have done this. You would have popped this in here. You would have changed that to garage, right? And obviously put the MAC address of that radio here, and that's all you would have to change, and then this would work just fine. Okay, so let's quickly, lastly, look at index.js here, and here's that send, right? So the event, again, the event is that, right? So we're doing a socket dot. We're doing our socket IO.emit, and we're emitting to a specific event, and we're sending a payload, right? So we're going to send the payload, is it hex, and we're going to send a pin, right? And that's it. So in case of a button, we call this directly. Now, in the case of, now this is when data comes through for an update, right? So we're listening for that update. In the case of your LED lights, what's going to happen here is we're going to call send data from here, as opposed to your buttons. We're just calling it directly from the HTML. So in this case, we're going to go through, and we're going to get that actual hex value that we have to pass. All right, so that's the only difference here, and you'll notice we're iterating through all of the checkboxes that have the same name, and all of the checkboxes do, right? So if you go up to these checkboxes, right, we end up getting a collection of all of these, right? And then we just iterate through. We parse out what we need out of the ID, and then the bench and the number. We figure out what color that we need to send, and we're good to go, right? And that's all we're doing here, and that's it. So let's see here. Anything else? I think that should probably be it. Again, if you're new to this stuff, put a whole bunch of console.logs to make your life easier. And then the last thing is the update, right? So we're listening for an update coming in, and it's do some logging here, right? Log out key or log out your state every time that you're going through, or what the key is inside of that state, and you'll basically what you're doing, or what I'm doing here, is building this. Right? So what ends up button, right? This right here ends up building well, not that version, but the button version, span version down here. So it ends up building that. Right, and that's all that happens. So you would end up having a little bit of an issue here if you had a button that's controlling anything greater than 9, because all I'm doing, right, the data here has pin 0, pin 1, pin 2, pin 3, and all I'm doing is pulling the number off the end. It's not very bulletproof, I guess, but I didn't have to go over 9, so I was good. So you might want to kind of rethink how you get that. And then down here, I just use the ternary operator. So if the value of that pin, right, so if that update comes in and the value is 0, it's off. And I just set the inner HTML to off. I set the color to black. Otherwise, right, colon, if else. Otherwise, I set it to on, and I set the color to a yellowy color, onish, right? And then down here, it's a little bit different, but it's the same thing, right? Well, this was what I originally did, right? So this is what we're building here, right? Based off the data, the radio, and the pin that came in, and we also got the a color, right? So with that update was an object that had RGB. So I also grabbed that color. I put a hashtag in front of it. And then I set the span, right? I set that actual span to be that color, So anytime somebody logs on, you can see that what the color of those lights are. Remember, if you haven't gone through the Raspberry Pi series, that series shows you how to set your entire server up so that you can just pull your phone up anywhere there's an internet connection. You don't have to be on your local host to check or navigate any of this stuff. All right, I assume that was probably a little bit verbose if you didn't need it, and maybe a little bit confusing if you did need it. But the best I can tell you, I'm going to show you right now how to get it up and running at least, and just put a bunch of do a bunch of console debugging, and eventually you'll wrap your head around it. It's not too bad. Okay, so let's we don't need this anymore. Let's close this, and I forget. Let's go to VNC here. 124 is my I might as well just use VNC. So I could SSH in, but let's use VNC to get in. I have VNC turned on the Pi. Now, folks, if you're running this as a server, I would recommend running it without a desktop, and then have a shared folder from your computer to the Pi or something like that for coding. However you choose to do it, or just code, push it up to a repo and then clone it back down on your Pi, whatever you need to do. Okay. So the only thing is, I don't know if this might be a little bit blurry here when I do it. Let's see here. That does not. Can we go to edit or something? Zoom in. What is it? Control, Shift Control plus. So Shift Control. There we go. You should be able to see that. All right, and we need the repository. Yeah, let's do this. I'm gonna go to PuTTY, and let's go to 192.168.1.124. And yes, we'll do Pi, Raspberry, and that way I can copy and paste. And we'll do this, and let's and we'll oh, yeah, you got to there we go. Cool. Okay, so now we have the repo on the Pi. Now we could just use Vim, or if you're tough, you could use Vim. I'm not, so I would use Nano or gedit or something like that. But let's just try to pull it up here. See how it looks in the. We'll see how it looks in the video. I don't know. So let's do CD. This should be here now. You can open up with code. I have code installed. And I guess the only bad part is I'm going to have to type in my MAC address. Let's see. You got to turn on. You have to turn on zooming, but I assume you're probably going to be able to see this just fine. And again, the only thing you need to change is this. Now, unless you did a different setup on your Arduino, you have to change the HTML a little bit, but really you just need to go to that bench radio, and you need to put in the address. And what is the address? So they're all for me S2's all. I guess for some reason I kept toggling the number lock, but 0013A200. So that's the low for all S2s. And then we're 40A2OE48. So 40A2OE48. And note that I don't do a case insensitive match, so you probably want to have your letters here as lowercase. Let's see, OE48. I think that's right. Do we have 16? Yeah, there we go. Odds are it's pretty good. Let's do Control S and Control tilde, and we'll need to do an npm install. Take a second. That's it. You don't have to change anything else. Well, I don't think so. That's funny. I finished this version probably 4 or 5 months ago, and then I changed it a lot for my own version. Added buttons instead of checkboxes, and obviously changed code here, there, and everywhere. So it's a little bit foreign when I went back to it. Like, really, you should leave some comments to yourself. All right, let's wing it. I've got my only now a couple of things you're going to have to do. All I did was I connected. And let's switch to my dock cam. So I've got my coordinator Raspberry Pi, and I didn't spend any real time with the Xbees. I'll let you do that. You know, the big thing is that you have to have a Xbee radio that can be in API mode. So an S2 or an S3. And I'm using API mode 1, so be in API mode 1. Depending on the firmware that you have, one's going to be a coordinator, the one attached to the Raspberry Pi, and then all the others, the ones attached to your modules. Your remote modules are going to be the router versions, right? So we have the coordinator, and then one coordinator only in router, and they're API mode 1, and they're all in the same network. So that's about it. Okay, so let's come back here, and I do apologize if this is a little bit small, but hopefully you can see it okay. We didn't need to change a lot. Now I'm just gonna do Node. I would install NodeMon, so everything keeps restarting as you're debugging your code and changing your code and such. But all right, so let's see here. I don't know. Come on. That's a good sign, right? So it's a good sign that we don't have that little shruggy guy, right? So we actually did get an update from the radio, and if we look here, right, you can see that the light is off here, and the LED is off, and the RGB LEDs have no color. So let's do this. Let's turn. So here we go. I know it's kind of small, but I'll make it bigger. So let's just do some tests here. Let's say on, and hopefully I know it's teeny down there, but you can see that we're on. Let's turn on with our lamp. Right, and again we can see the state. Let's pick a color, and let's pick just the bench strip to set that color, and that color did change. Let's uncheck that, and you'll notice, right, we update the color here, and let's pick maybe something like nice and blue, and that single is now nice and blue. Oop. And here, let's just do that so you can see it, right? So you can see everything worked just fine, and I'll just toggle a whole bunch of stuff off here. And shut off all the lights, right? So everything works as expected, which is fantastic. And I know I was kind of throughout this I was a bit wordy, which tends to be my nature. I like talking about this stuff, but hopefully you realize how little you had to do to actually get up and running, or at least how little code you had to change. Now, excuse me. At the end of the Arduino video, I got us out of debug mode, and I moved RxTX to 0 and 1 on the Arduino. You're going to want to leave it at 2 and 3, and you're going to have debug windows open, right? So basically you're going to have 3 debug windows open as you start doing this. The good thing about this is if you have the patience to do this, you kind of become the ultimate problem solver. You're going to have a debug window open for your C code in Arduino. You're going to have a debug window open for your client app, right? So F12 in Firefox and probably Chrome and everything else. And then you're going to have the debug window open in VS Code for the server. And at all times, you're going to need to be juggling the three of those. Now, hopefully, this will at least let you get it up and running quickly. But I got to tell you, to get this all working right, I had all three of those up and running, and it, didn't take me a super long time because I've been doing it a while. But there was definitely some debugging and trying to write code to make things a little bit cleaner, and printing out what I had because I didn't know exactly what the heck it was and how I'd iterate through it. So you got to print it out so you could then kind of see it and visually like, okay, yeah, now I know what it is, and I can go attack it and strip stuff out of it that I need to change a button color or whatever. So I hope it helped. Feel free to send an email if you ever have questions. Obviously, if you're one of my students, then you have no problem with that. And I will I'll get all the videos and the code up, and I will do that last supplemental video at some point. Probably won't take me too long to get that one up too. Okay, I hope it helped.